My name is Cheryl Asa, and I work at the St. Louis Zoo. I'm the director of the research program at the zoo, and our current research focuses mostly on behavior and physiology of reproductive processes. So we do what maybe the average person would think of captive breeding research at the zoo. The research we do focuses on behavior and physiology. So in behavior, we have people who do old-fashioned just observations with paper and pencil. That still works really well, but all that ends up going into computers. And we rely more and more on automated methods, such as video, because it's non-intrusive. The animals don't even know you're there watching. And computer systems that interface with video that make that analysis easier. And remote kind of technology such as Fitbits. So we have a new project with little fennec foxes with Fitbits on their collars that show us their activity rhythms 24 hours a day. So the methods are interesting. First, the older one, the first article that came from work done in the late 1880s was what we would call descriptive. So it was someone, probably a naturalist, who was out just watching birds in their natural environment and describing what happened. And we still do descriptive work, but we focus in a way that it didn't seem that he did. For instance, his articles, his writing was very long, and what we would consider very wordy. We're always encouraged to be much more focused and more concise in our writing. So journal articles have changed a lot in 100, 150 years in that regard. I think from reading the articles that you sent from the transactions, what struck me most was perhaps the tightening of experimental design and study design and the introduction of statistics. And even though one of those studies could be considered experimental because the animals were being manipulated and then observed, it wasn't the kind of controlled experiments we would do now with replicates so that we could do statistical analysis. So even though it was experimental, it was still in many ways descriptive and just a simple summary of the observation. Since there were no replicates, it wasn't truly quantitative. And I think that's a huge advance for science, the development of scientific method and statistical analysis. Well, as a scientist and someone who thinks science is so important, it worries me if we don't have enough young people who are engaged in science and who become the science leaders of the future. That is the future of our country in so many ways. And I think the programs the Science Academy has are one wonderful way to get kids excited and engaged in science. And in our own program at the zoo, we have an extensive internship program. And so students can come for just one semester or can stay a year and can get some practical experience. We had one student from the University of Missouri, St. Louis, get so excited within a week or so of being with us saying, I've been studying this in a textbook and now I see how it actually works. It's real. And so that, putting the science in action and giving students an idea of what the profession is like and how you actually apply those sort of esoteric things that they're seeing in textbooks, I think is really important. There are so many opportunities, things that I don't know that we could even imagine in terms of research, but for kids to get involved, I think St. Louis has a great number of programs for students to volunteer or to get credit, internship credit, or to go work in labs. I know the St. Louis University, Washington University, as well as the zoo and the Science Center have a lot of opportunities if kids take the initiative to go find out about them.